a corresponding delta greater than 0, such that for all x 0 less than modulus x minus c less than delta. So for this domain we get the range as fx greater than b. Fx greater than b. Or we say that fx approaches minus infinity as x approaches c. In this graph, fx is approaching minus infinity below, fx approaching minus infinity as x approaches c. So 0 less than, here we have modulus x minus c less than delta. So for this it corresponds to fx less than minus b. So if we say if we are in this range, in this range we look at basically, so between this range or this range or this range, fx will be always less than minus b. You can see here in this range fx is less than minus b. Fx less than minus b, here we have for this 0 less than modulus x minus c less than delta. Example 14 now. To prove that limit x tend to 0, 1 by x is equal to infinity. Given is b greater than 0. We want to find out delta greater than 0 such that 0 less than modulus x minus 0 less than delta implies 1 by x square greater than b. So let me first go through this again. Fx is greater than b, here we have. For 0 less than modulus x minus c less than delta. So this we use here in this. It implies now 1 by x square greater than b. So 1 by x square greater than b if and only if x square less than 1 by b. So from here we have now modulus x is less than 1 by root b. We take now here square root both sides. We take now square root both sides, here we have. So modulus x is less than 1 by root b. So from here we have delta equal to 1 by root b.
Or minus 1 by root b.
Delta equals 1 by root b we can take here. So from here we have modulus x less than delta. It implies 1 by x square is greater than, now b is, from here delta is equal to 1 by root b. So square both sides, delta square is equal to 1 by b square, or b square is 1 by delta square.
Okay, this part is okay.
Yes.
This part is okay. Now here
1 by x square greater than we have 1 by delta square.
So 1 by x square is greater than 1 by
Delta square is greater than or equal to b, here we have.
Because you are putting what? Delta is equal to 1 by b square. 1 by root b.
Delta is 1 by root b, yeah. Delta square is 1 by b square, or b square is 1 by delta square.
Okay.
So here we now limit x tend to 0, 1 by x square, that will become equal to infinity. Limit x tend to 0, 1 by x square is equal to infinity, here we have. Next we have now the vertical asymptotes. So horizontal one we have already done. Now let us discuss the vertical asymptotes. Here we have now vertical asymptotes. Here we have. So now here we have for the vertical asymptotes as x tend to 0 plus. As x tend to 0 plus, the function leads to infinity, and as x tend to 0 minus, the function leads to minus infinity. As x tend to 0 plus, the function leads to infinity, or x tends to 0 minus, the function leads to minus infinity. Now we see the line x equal to 0 here. This line is the vertical asymptote for the given function. The definition is given as a line x is equal to a is the vertical asymptote of the graph of function y equal to fx if either limit x tend to a plus fx equals plus minus infinity, limit x tend to a minus fx equals again plus minus infinity. So as x approaches a plus or a minus, if the function goes to infinity, we can say there is a vertical asymptote. Now, you can write here the definition of horizontal asymptote. So same here for the in the limit terms of limits here we have write the equation for horizontal asymptotes.
The definition was well that the limit of f of x is equal to infinity. Right?
Limit of you have to write this here limit of for horizontal asymptote.
Yeah, right, but that was it.
Mm-hmm.
That was vertical. Horizontal one was f of x equal to b. Yeah. Right.
Here we have now limit x tends to infinity. Yeah, perfect. Yes, please go through this example now here and find the horizontal and vertical asymptote of the curve here we have. Learn the method now.
Yeah. Hello.
Yeah. So have you got a solution here? Okay, take your time.
Well, we are interested in the behavior as x tends to infinity because that's where you get the horizontal asymptote, right?
Yes, yes.
Get the how do you get? Why do you have to make the denominator 0? How does that help you?
Denominator as 0. No. Let me tell you how to find the horizontal and vertical asymptote here. Very simple method, okay?
Yeah.
Let me give you the concept here. So here we have y equal to x plus 3 by x by 2. My x plus 2 here we have.
Yeah.
So now let's find out here first of all the horizontal asymptote. So limit x tends to infinity, for example, x plus 3 by x plus 2. So limit x tends to infinity, here we have x common 1 plus 3 by x, okay, my x common, so 1 plus 2 by x.
Yeah.
This cancels out, so it is 0, so 1 by 1 is 1. So we get here y equal to 1 is the horizontal asymptote. Getting it?
Yeah.
Now how to find the vertical asymptote? The method is to find out vertical asymptote. So we have now y will be at vertical asymptote, you have y is infinity. So we can put y as infinity, right? That is 1 by 0 is equal to, that's the method only, 1 by 0 is equal to x plus 3 by x plus 2.
Okay.
So from here we get x plus 2 is equal to 0, cross multiplication, or x is equal to minus 2.
Right. That is how you get the vertical.
Yes, here we have x is equal to minus 2.
Okay, like that.
Yeah.
Getting the answer equal to 1 by 0.
Yeah, for finding out the vertical asymptote, put y as 1 by 0. For finding out the horizontal asymptote, put the limit x tends to infinity. That's it. You will get the asymptotes. And now, how to draw the graph here? So for the graph, You have the asymptote horizontal one, y equal to 1, vertical one, x equal to -2. Now let's draw the graph here. Horizontal here we have y equal to 1,
Yeah. So so it will never go past that.
vertical here we have x equal to -2.
Yeah. Yeah. So now how do you draw the graph?
The graph is coming out to be like this. Now we have to just look at some points here. It is x plus 3 by x plus 2, right?
Yeah.
What you can do, let's take here x as 0 for example, okay?
Yeah.
When you put here x as 0, just take 1 or 2 point. 0 plus 3 by 0 plus 2, that is 3 by 2, 1.5.
Yeah. But that is not part.
No, that is there, 1.5 here we have, 1.5. So that means that means the graph is like this one and this one. Are you getting it? And here it will be just a mirror.
Okay. So how? Okay. You substitute some values and then you see.
Yeah, absolutely.
Okay.
Okay.
Yeah.
Example 16 here we have now. Fx equals -8 by x square minus 4.
Yeah.
So here we have complete solution for that. Now please go by same method and just find out the asymptotes and draw the graph.
Yeah.
Yeah.
Then graph of 8 by x square by. So I'll just push it to the side also.
Yeah.
Okay. So you say x tends to infinity,
Mm-hmm.
right? So then minus 8 by x. So this is 8 by infinity is 0, 0 divided by
Mm-hmm.
infinity
Okay.
and 0 only. Because this
Okay.
is 0 minus 0 is 1
Yeah.
and this is infinity.
So draw the graph now.
Yeah, so the limit horizontal limit is 0,
Mm-hmm.
vertical limit um, you said 1 divided by 0
Yes.
is equal to minus 8 by x square.
Okay.
And now so x square
Mm-hmm.
minus 0, x is equal to 2,
Yes.
right?
Okay, yes, yes, yes.
So plus minus, which one do you take? You take both.
Yes, if the value of x is coming, yeah, we take both, yes, why not? Let me just confirm, let me confirm here with the given graph. Where's the given graph? This
Yeah,
one.
there.
Yeah. Continue.
And now, well, now we have these limits. So now to find out how it works, how that graph looks like, only that is the calculation.
Yeah.
So,
So I think you are clear with this now.
yeah, I'm clear, but it's one question.
Mm-hmm.
No. Wait. Okay, so now we have a horizontal limit at 0,
Mm-hmm.
but we don't need to draw it. This is the axis.
Yeah.
Now we have 2 and minus 2.
Okay.
Right? So
Mm-hmm.
how do you now just have to substitute values, is it? And now how you get the answer, how you can draw it is just by substituting values, is it?
See,